So here we go. We're going to cover Introduction to Transformations today. This will be a place to start if you missed class or if you want to review the topic we've been covering lately. So we have some shapes on the board right now, right? There's a three-dimensional transformation, all right? And we see that there's time involved, right? And so maybe it's even a four-dimensional transformation, right? And we got things getting bigger, smaller, getting reflected, rotated, they're getting translated. Every single transformation is happening at the same time. So I'm putting this here to illustrate where we might be going, okay? Transformations are highly applicable to like computer graphics and stuff like this. So let's start the basics of transformation. All right, the word itself, transformation, right? Trans means across, and form means shape, right? So this is saying to go across shapes. So we have several different shapes, so it can mean changing shape, right? So the idea of this word is encapsulated in these two morphemes, right, of trans and form. So keep that in mind. It all means is that we're really changing the way something looks, okay? Now, sometimes the transformation doesn't actually change the way it looks. It just changes the place where something is. So those kind of transformations are called translations, all right? When we only move something up and down, left and right without rotating it, all right? We're also going to study reflections and rotations. And dilations will be something that you study in math too, but that's another kind of transformation that will briefly introduce the idea of it, okay? So, again, a translation is like this, all right? This triangle started over here on the left and then moved to the right, and so we would call this a translation right. You can see that this point B is moving 1, 2, 3, 4, 5, 6, 7 units before it becomes the point B prime, okay? So I would say this is a translation to the right 7 units, okay? Notice that the ones that don't have this little mark, okay, are the ones where we started, and the N was over here, okay? So the ones without the mark are before we do it, and this is after we move it, okay? So that's a translation. A reflection is like this, okay? It's where something gets reflected so that it's on the other side. So like if the line was like a mirror, and we're going to see a mirror image of the shape. So we'll give some technical definitions of that too. Then we're going to cover rotations. Okay, so rotation is something like this, right? Where we see a point is rotating about another point. In this case, we have this point rotating around the center. And that's rotating around another thing that makes this special shape called the asteroid. Okay, so that's what a rotation is. Then we have this thing called a dilation. Okay, so when you have a shape that gets bigger, but doesn't actually change its shape or its proportions, right? We call that a dilation. The whole thing is just getting bigger or smaller, so it's kind of like zooming in or zooming out on your phone, right? It doesn't change the shape. It just gives us like a bigger close-up view of it. All right, so again, this is what we're looking at, right? Like I said, translation is like on your phone when you're swiping up, down, left, and right. A rotation would be like where you put one finger down and then you swipe in a circle to kind of rotate something around, right? And a dilation is like where you click with 2 fingers and you kind of zoom in on something, right? So just understand the difference between translation, rotation, and dilation, all right? These different types of transformations. All right. The axis of symmetry is the line of reflection. So one thing that we're going to get when we talk about reflections is this idea of a mirror, right? The thing that we're reflecting across. So the thing that we reflect across can be called a line of reflection. And another thing that it can be called is the axis of symmetry. So you would want to know both of these words and understand that they're interchangeable, okay? Notice that a reflection of a point will go to the other side of the line of reflection, and they'll always be the same distance from the line of reflection, okay? And that's what makes that distance equal. That's what makes it a mirror image, right? So, you know, that's the way a reflection works, all right? Now, let's get more basics of a transformation, okay? So, with any transformation, okay, before I move it, we call that the pre-image of the transformation, okay? And then when I follow the rules of the transformation, like if it tells me to move it down and to the right or up and to the left, okay, we call that the image after I do that move, right? So this is what we have, the pre-image. Again, remember, pre means before, okay? So the pre-image is before we move it. And the ones with the little prime marks are how we can tell what happened after, okay? So This brings us into the actual practice problems. So we'll get into this assignment right now, and let's just begin working. So we can see that for number 1, we have to move this shape 2 units left and 2 units down. Okay? We did this one in class, and we can see that the answer was as shown right here. Okay? We can see that the point R went 1, 2 left, and then 1, 2 down. And then we wrote the name as R prime. When I move the point S, I'm going to go 2 units left and 2 units down, and then I will call that S prime. And now for Q, I'm going to move it 2 units left and 2 units down, and I will call that Q prime. Okay? Now this, what you have here, is complete. Okay? The shape has been translated. Notice that it didn't get rotated at all, right? The R is still the highest point, the S is the one on the left, and the Q is the one all the way at the bottom. Alright? Number 2 should look like this. We did this in class also. So again, notice that all the points got moved, 1 to the right, and then up 4 units, right? So this is all we have to do here. So now I would kind of motivate you to try number 3 on your own. This was a homework problem, and the answer is in your answer key. So you should be able to see what we should have got will be a shape like this. Okay, notice that E is moving 4 steps to the left and 1 down. D is moving 4 to the left and 1 down. C is going 4 to the left and 1 down. And F, I go 4 to the left and 1 down, and I call it F prime. Okay, so after you move a point, you label the same letter, but then you just put that little mark on it, and then we read it as E prime. Okay, so we got the transformations that we need right now. Okay, so for number 4, you guys should consider how to do this problem. Try to move it, pause the video, and at least get a wrong answer so that we can fix it together when I give the answer right now. Okay, so I hope you did it. I'm revealing the answer, and the answer should look like this. Okay, again, notice that F, for instance, is going to move 6 to the right and then 2 units down, and then we call it F prime. And likewise for G, H, and I. Okay, so again, like I said, that is just the basic one when we give you the directions in words. Okay, but if I don't give you the directions in words, that means we got arrow notation, something that looks like this. Okay, so to understand what this means, we're going to jump into one of the slides I made. This one right here. What you guys want to do is maybe take a screenshot of this or digest this right now and understand that the number that goes in the entry with X, right, the one that goes in the left, okay, is telling me how the X changes. So this one is saying that X will change into X plus 3, which means I got to move to the right. Whereas this one tells me, well, X's change is going to minus 3. So that means that we'll go to the left instead of the right. Okay, in these 2 cases, notice that nothing is there for the X, right? So that means we're not going to go left or right. Okay, but because something's with the Y, that tells us that we're going to go up or down. So when we have a positive value for Y, that moves us up, okay, in the Y direction. And a minus in the Y is going to give us a down. Okay, so in this case, we'd be going 3 units down. So this is the idea that you need to have really solid to be able to do these problems. And to do this one, we want to understand what kind of directions is it giving us, right? It's telling us to move blank units, blank, and then to go blank units, blank. Okay, what words do you think I'm going to put in there? All right, well, the first one is to determine whether or not the X is moving us left or right. Again, a negative number moves us to the left, and a positive moves us right. Well, that's a negative 6. So it wants us to go 6 units left. Okay? And because this Y, okay, is negative, well, a positive value for Y would move us up, but a negative value in the Y is going to move us down. So this means that we have 6, and instead of going up, we're going to go down. Okay? So this is actually what I want you guys to do on all of these problems. Okay? I really want you guys to be able to write down in words what's happening, because if you can't do that, you're definitely you're going to be kind of guessing a little bit too much. All right? So it should be an easy thing for you to do, to write that. So number 6, I believe we did number 6 in class. All right, but I'll show the answer up here. You should have something that looks like this. Again, everything going right 2 and up 1. All right? So notice they're both positive, so we go to the right and up. All right, so now number 7, another homework problem. This one should have us going right 3 and up 1. Okay, so I hope that makes sense to you. Number 8 is a homework problem we did in class, maybe, for most of my classes. So this one will be moving as x minus 1. That means go right or left. What does this mean? A negative direction is the left. So this means go left 1. But y plus 1 means that I have to go up 1 unit, right? So this would be the answer that I have here. And on the side, you would write left 1 unit and up 1 unit. All right, we'll go ahead and move on to number 9. And I believe we did that one in class too. You can see that there's nothing in the x column. So all this means is that I only have to push my thing 4 units up. So nothing goes left or right at all. All the points just move straight up. All right, number 10. This would be a good one for you guys to do on your own. I guess I'll give away the answer just because it's a YouTube video. But you should pause the video and make sure you know how to do this on your own so that you get some kind of a sense of how confident you could be. All right, again, does this mean left or right? And does this mean up or down? That's the idea you need to make in your mind. Okay, well, I hope you realize that this means 2 units left and then 2 units up. So you should have this for number 10. All right. The next problems that we have in this set, all right, will be something like number 12 is another even problem you didn't have the answer to. So notice that it's just going to the right 2. And because y has absolutely nothing in there, that means we don't go up or down. We're only going left or right. And in this case, we're going right because, you know, it's positive. Okay? So we'll take a look at 13 and 14 we did in class. Okay? But I'll project the answers to 14 in case you didn't see them. Okay? So that's what you should have got. Again, the x-coordinate is moving right. So that means the x-coordinate should increase by 1. And the y-coordinate should increase by 4. So notice 0 plus 1 is 1. And negative 4 plus 4 is 0. So in this case, we have 15 and 16 I decided to scratch, so you guys go ahead and take those problems off. We'll do those on another day. Okay, and then 17, 18, 19, and 20, we did these in class, so I'll reveal the answers. But again, we really wanted to do these with multiple choice, all right? So I'll probably, I think I'm going to try to do all 4 of these right here, just next to each other. As crazy as that sounds, just do them like this, all right? So the big idea here is that we should see on A, this is telling me that the x doesn't change, right? But we can see that all of these x values do change. Look, none of them are the same, right? All of them have changed to another number. So that means that A is just not true. It's not true that x is going to change into x. These numbers are changing, okay? Now we can go look at D, for instance, right now. And we can see this says that y is going to be adding 2 to each y coordinate, okay? But think about it. What is 1 plus 2? 1 plus 2 is not 2. So this cannot be the answer. It can't be D either. So now I have to make my mind up between B and C. But let's take a look at C. All right, C says x minus 1, right? But minus 1 means to the left. And so we can look at it like, is negative 4 minus 1 equal to 1? That's definitely not true. So I can cross out C also. And we would be able to see that the answer has to be option B. Okay, this also makes sense because we can see that all of these numbers got 5 added to them. Plus 5, right? Plus 5 every single time, okay? And on the other case, we had every single number got plus 1. Look at that, plus 1, right? Plus 1 and plus 1. So if you can see, the point that I'm trying to make is that you should be able to eliminate all of the choices. And that would only be a consequence of you understanding how to read this notation, right? There's no way around it, so you got to understand that I'm trying to put up a roadblock so that you can't get around this without knowing how to read arrow notation, okay? So again, let's look at what this is saying, okay? A is telling me that x turns into x, that the x does not change, right? Notice that C also says that, right? That says the x doesn't change, but look, these two x coordinates are different, right? That's the I and that's the I prime. But they have different numbers, okay? The L and the L prime, look, those x's are different. They're not the same. So that means that A cannot be the rule that describes this, okay? It's got to be B or D, okay? And you can probably figure out what it's going to be. What do I add to negative 5 and then I get positive 2? It's got to be 7, okay? Which one of these is adding 7? Well, that's only B. So B has to be the option here, okay? So you guys should do the other ones also like that. I want to leave you guys a little bit of work to do, okay? But like I said, cross out the ones that you know it cannot be. Okay, for instance, on 19, I'll give you one last clue. All right, let's look at this one. This one says that y has to be minus 4. Okay, but let's look at m and m prime. Is 5 minus 4 equal to 2? No. So that means that this cannot be the rule. You get me? Okay, so continue crossing things out and use that strategy. Otherwise, you guys are just guessing. Okay? Or you might even be doing it inefficiently. You might be doing too much work. Okay, 21 and 22 we did in class because we wanted to know, right, that the pre-image is before I move it and the image is after I move it, and that's the one that's in blue in this case, right? That's the one that basically has the tick mark, right? That little mark is W prime, that's after. Okay, so like I was telling my students, right, it depends what's the beginning, right? Is this shape going up or is it going down? Okay, well, since we know that the W was before and W prime is after, this means it's going up, right? Okay, so that would tell me like I could cross out D, because look at what D says. D says that Y turns into Y, which means that that it doesn't go up at all. It goes up 0 units, but we can see that it definitely goes up. So that means the answer can't be D. Okay, look at C. C is telling us that these points are all going up 4 units, but let's count. V, 1, 2, 3, 4. All right, B does not go up 4 units. B only goes up 3 units. So it can't be C. And now we already suspect that the answer is B. And because we know that this one doesn't have a 3, it can't possibly be this either. Look, I don't go up 2 units. Look, 1, 2. That's not enough. B has to go up 3 units. So that means that the answer for this one should be B. Okay? And likewise for this one, the answer would be A. All right, and I know we revealed that answer in class too, so if you weren't in class, use those to help you out there, okay? The big idea here is that we know that before is the one that does not have the little mark, okay? So you got to understand that Q prime is after, all right? So the big idea that I made everybody write in class on this specific problem was that we need to know that this one is the pre-image, okay? The pre-image, again, is before we move it, and the image is after I move it. And so that's why we know that this is going up and to the left, okay? Because I look at those marks, and that tells me everything. So here we get to these word problems. Always, sometimes, never. And the idea is that I really want you guys to spend some time thinking about the words and encountering, you know, some synonyms even, right? Words that mean the same thing as something else that we might need. So this idea of orientation, we're going to talk about right now using like a little triangle, okay? Right now, I am translating the triangle up, okay? Right now, I'm translating the triangle left. Now I'm translating it down, and now I'm translating it right. You see what I mean? When you translate something, all right, it does not move, right? It just actually keeps it exactly where it was, okay? I mean, it moves it, but it doesn't move it relative to itself, right? It doesn't get rotated. So notice when I'm transforming it now, I am not translating it, okay? If I move something up here and then rotate it, that's not a translation, okay? So when we say we're translating something, that means we are not changing the orientation, okay? So when is this true? This is always true, all right? That's when it's true. It's always true because that's the meaning of this, okay? What we're talking about here in this case is the definition of a translation, okay? If you translate something, then you cannot change its orientation, all right? Now, the next thing we got is 24, all right? If a point is reflected across the x-axis, then its y-coordinate will not change, all right? This is kind of a big idea, and so this will be one of the last big topics we talk about in this video. What we want to discuss is what happens when we reflect something across the x-axis, right? So I always tell my students, when you know we're going to reflect across something, go underline it, go darken the thing in the picture so you know what we're looking at, okay? I want to reflect across that, okay? And it says if a point is reflected, so that means any point, just be anything, okay? If it's reflected across the x-axis, does that mean that its y-coordinate will not change? Okay, stay focused on that. Let's do an experiment, okay? To figure that out, we'll put a point up here, and we'll call it A. And then we'll go down here, and we'll call another point A prime. Okay, this point that we have here is the reflection of A. Okay, the distance from here to here is 3, and the distance from here to here is 3. Okay, and that's what a reflection is. A reflection is always going to move at a right angle, and it's going to be the same distance as the other point is from our axis of symmetry. Okay, so let's look at what happened though. What's the coordinates of this point A? That's y equals 2. Okay, again, because if you guys could see, that's the point 1, and that's point 2 right there, yeah? So what I'm trying to show you is that the coordinates of this point are 2, 3, but the coordinates of this point are 2, negative 3. Okay? So what happened? We reflected this point. Did its y coordinate not change? Well, I don't know. What's the y coordinate? X, y? X, y. Hey, wait a minute. This point got reflected, and its y coordinate changed from 3 to negative 3. Okay? So in this case, we have just uncovered a situation that says it will change, right? So it seems like so far this isn't true. We don't have evidence that it's true that it will not change if I reflect over the x, okay? But let's think about another point right here. What if I have a point B, okay? Well, again, the whole point of reflection is to go the same distance from the mirror, right? So if I have a point C and it's 1 away, then the reflection C prime is going to also be 1 away, all right? But what if a point is right on top of the mirror? If a point is right on top of it, then the reflection does not move. So the point can't move, and when I reflect it, it stays put in the same location, which means that its y coordinate will not change, right? So that means sometimes you can reflect the point across the x-axis, but its coordinate doesn't change, okay? That's sometimes true. And it's only true when a point is directly on the x-axis. So the way to solve these problems, these are actually probably the most sophisticated problems I gave you guys on this assignment, is because you have to do some experiments and you'll have to test to see what's happening, okay? So draw some points, reflect them across the y-axis, and see whether or not they do what you think they're supposed to do, okay? We're going to have a longer conversation in class about these problems, so I'll move past them right now, okay? We'll get into the reflections before we finish this video. So the first thing I tell people to do is understand we're doing a reflection across the x-axis. So put it in a box and then darken the x-axis. Again, that's this one, the one that says x, okay? Well, now I have to reflect across the x-axis. So what that means is we need to count our distance, okay? E is 4 steps away, so that means E prime is going to be another 4 steps away. Okay, these little lines that I drew don't have to be drawn. I'm just showing you there so you can understand what I'm doing. Okay, now the same thing for G. Okay, I can see that G is how many steps away? It's 1, 2, 3, 4, 5 steps away from the mirror. And so I have to go another 5 steps, and that will put me right here, and that's G prime. F is only 1, 2, 3 steps away, so I have to go another 3 steps away and call that point F prime. Okay, and again, like I said, all those other little marks don't have to be there. I just wrote them so you could see what I was counting. And now if we connect our points, we've done our reflection. All right, this point has been reflected. Again, don't forget this is the pre-image, right? That's before we moved it, before we reflected it. And then after we reflected it, it got brought to the top. Okay, so notice a reflection means that the points will go to the other side of the mirror. So the points go from the bottom to the top or from the left to the right. So taking a look at 30, this is one you guys could do on your own. Okay, you should probably try it and I will project the answer. Okay, you guys should have something that looks like this. Okay, again, look at S. Okay, the point S was directly on the x-axis, so that's why it doesn't move anywhere. It just stays put. So S prime ends up being right on top of S. Okay, so be careful for this one. Again, that's a reflection across the x-axis. The points from the top go to the bottom. All right, now let's do a reflection across the y-axis before we get to the harder problems. So in this case, again, underline the y-axis so that you're forcing your brain to read what you got to read and you're not just trying to get work done without thinking about it. Okay? I'm going to reflect j across the y-axis, but that's 4 steps, so I go another 4 steps, and I call that a j prime. I is 3 steps away, so I go another 3 steps that direction, and I call that I prime. H is 5 steps away, right? 1, 2, 3, 4, 5. So I got to count another 5 steps, and that's where H prime goes. Okay? And there we have it. Our triangle has been reflected across the y-axis. So notice, when you reflect across the y-axis, our shape ends up moving from left to right. So now we'll take a look at number 32. All right, now we didn't have an answer in the answer key, so let's see if you did this one correctly. Okay, look how E is right on the y-axis. That means that point won't move. Okay, so that means we should have 32 looking just like this. All right, now 33 and 34, those are 2 that I'm going to leave for you guys to do as homework. 34 doesn't have an answer key, so you guys can, show me that tomorrow if you're confused about it. Let's do 35. We did this one in class, okay, so we'll talk about these ones where you have to graph horizontal vertical lines. All right, this is the end of the lesson. So y equals -1, okay? In order to graph y equals -1, I'm going to go to the y-axis. And I'm going to go to this number -1, and I'm going to make that little tick mark, okay? That's -1, right? Okay? What I do is I take that mark and make it really, really long, okay? And that's how I draw the line, y equals -1, okay? Every point on that red line that I just drew has y equals -1, and so that's why we call it y equals -1. Okay, so now what I do is reflect everything across that. But notice that A is right on it. So that means A prime doesn't move because it's right on top of the mirror. Okay, but D is 1 away, right? So I got to put D prime on the top, right? Notice the ones on the bottom go to the top, but the ones on the top are going to go to the bottom. So I'm always going to count back toward the mirror. So 1, 2, 3, 4 steps. So that means I got to count another 1, 2, 3, 4 steps. And my point is right there, and that's C prime. Okay, I only have 1 point left to graph. So let's get that one. We'll look at B. And we can see that it's 4 steps, so I got to count another 4, and that means that B prime will go right there next to C prime. And if I connect my points, we're complete with this exercise, all right? So we have a horizontal line, okay? So don't forget that because y is equal to -1, that's why this is a horizontal line, okay? Because we don't want the y to change, okay? And if your line goes up or down, that means that your y values are changing, okay? So keep that in mind, okay? You guys are going to have to make a couple mistakes here and there, maybe before you truly master this topic. So we'll take a look at 37, all right? 37 has us reflecting across x equals -3, okay? So the y equals were horizontal lines, all right? Well, the x equals is a vertical line. And let's try to figure out how can we remember that. How can we remember that an x equals is vertical lines? Well, I have an easy way. You go look at the x-axis, and then you go look at -3. That's right here, yeah? Okay. Remember, look at this mark. Is this vertical or horizontal? It's vertical, so that means that we have to label that as the line x equals -3. Okay, and that is the line that I'm reflecting everything across now, right? So notice that these 3 points, P, Q, and R, they're on the left side. So when I reflect them, they're going to go to the right. But S is on the right side. So when I reflect S, S should go to the left. So let's do S first, all right? S is 2 away, right? 1, 2. So I go another 2 steps, 1, 2, and I call that point S prime, okay? I'm going to erase those little marks, because again, I'm just trying to show you guys what I'm trying to count. Okay, so let's move the other points. If you understand what I'm talking about, this might be a moment to pause the video and wrap it up on your own. Okay, if I take 1 step to the right, that's R prime. Okay, Q is going to be 2 steps to the right, right next to R. And then P is 2 away, so I'm going to put P prime right there. And now all I have to do is connect my points. All right, so just be careful when you do that, and your line should look symmetric. I missed a little bit when I did that, so it probably should have crossed right there, and it will look a little better. All right. So if you got my point now, this is the way that we do a reflection. Okay, we want to understand that an x equals is going to give us a vertical line, and a y equals is going to give us a horizontal line. Okay, how can we remember this? All right, again, I'm trying to really make sure that I don't have to explain this 1,000 times. All right, the y equals lines are all like this, right? Think about it. This line is y equals 1. This line is y equals 2. This line is y equals 3. All right, that's the way it works. If I do the other way around, right, my x, right, my numbers, right, that's 1, that's 2, that's 3. How do I remember that the x ones are vertical lines? Well, the way that you remember that is because the tick marks go vertical, all right? Go the same way that this mark goes, up and down, all right? So, do a couple more examples, and it looks like we're about done here. So, we'll do 38. All right, this is an even one, so there's no answer key for you guys, so let's help you guys get this one. All right, we got x equals 1. So that means I go to x. I go to the little tick mark for 1, and that reminds me, oh yeah, x is the vertical line. So now I make my vertical line. Okay? And now we reflect all of our points. G is 1 away from the mirror, so that means G prime is going to be on that side. F is 4 away, so that means F prime will be 4 on this side. And H is 1 away, so H prime will go to the right side of the mirror. Okay, and then connect them. And again, notice that these 2 points move to the other side of the mirror, and this point move to the other side of the mirror. So everything just has to go to the other side because that's what a reflection is. All right? So we're going to get this last one, and this will be the end of the video. All right? So in this case, we got y equals -1. Let's see if there's a better example. 40. I'll do 40 because you guys don't have an example of that. All right. So in this case, we got x equals 1 yet again. All right. So this is the line at x equals 1. So if I reflect my m, that's m prime. L is 2 away, so I got to go another 2. N is only 1 away, so I got to go another 1 and call that n prime. Okay. And you can see if I connect my dots, that's my shape, right? This triangle is the same as that other one, and they're all connected. All right, I think you guys should be able to take it from here. I hope that was enough review. I think maybe on this one we could talk just briefly about the way that you could do 39 would be that I want you guys to highlight this, right? And understand that's y equals -1. So what do? I go to the y-axis, and I go to -1, right? That's -1 right there. And I take that line, and that reminds me that, oh yeah, the y lines are going to be horizontal. All right, so that's the line y equals -1. Okay, and if I reflect everything across that, I'll be done. Okay, so this is for you. You guys got that in your answer key, so you'll be able to do this. All right, I'll cut off the video right here at 33 minutes. All right, good luck getting your homework done, everybody.